Are we live? Okay. Hello and good morning, everyone. Swapnil, can you hear me?
Yes, perfectly.
Okay. Uh, so let me admit there are people waiting. And, so I request everybody to be on mute except the speaker. And you will have a chance to interact with the speaker at the end of the talk. So hi, Swapnil. Ladies and gentlemen, this is myself, Riddhi, and who is the host of the day, and Swapnil, our speaker of the day. And we have other participants also. Um, this is the talk is being streamed on Null YouTube channel right now. What is Null? I hope a lot of you are aware. Some of you might not be aware. Null is an open source security community. And
Riddhi, if I may interrupt you, I do not see the stream live on YouTube.
I think it is live. Just a moment. Check this.
It still says waiting. Let me check that.
Okay.
Okay. I think that looks good. Yes. Please go ahead.
Okay. So NAL is an open security community, and we conduct a lot of events every month. Ever since the lockdown has started, we have started experimenting with online events. We have various formats of events, and today what we are having is talk. And Swapnil has voluntarily, so we didn't have to go and ask people that speak. He voluntarily said he wants to speak on a topic of his choice, and this is the talk that you are attending right now. And that's how we want to conduct all the sessions. So, any of you ever feel like giving a talk or giving a hands-on session, please do reach out to us on Discord. Discord link is on the null.co.in page. You can access it, you can join us, and you can interact with us. And in Null, we have various formats, Null Hamla, Null Bachao, Null Pulia, and recently we also started Null Kriya. Uh, I will tell you more about it towards the end because we are already, already going to be 9:30. And now I would allow Swapnil to take over and start the sessions. Swapnil, it's over to you.
Thank you, Riddhi. Let me go ahead and share my screen. Yeah. Can you confirm if the screen is visible as well as my voice is
Yes,
clear and audible?
yes.
Okay.
Audience,
Great.
you can chat and you can message on the chat if you want to say something while the talk is going on.
Okay. Um, Let me see the chat and try to open it in a different window as well, so I can get a. All right. So welcome everyone. At this hour, especially, it's primarily midnight for me usually. But good morning and welcome. And I hope that people who have joined as well as who will join in probably in the coming few minutes will find this talk interesting as well. So what I'm going to talk about is uncovering badness using passive DNS, and I'll talk about what is passive DNS and then who should be using it for that matter. A little bit about me. So who am I? I am primarily a network engineer working on network and security, and as well as more specifically DNS, DNSSEC, as well as BGP. I'm a technical trainer as well. I regularly conduct workshops on DNS, network security, DNSSEC, Unix systems as well. I'm an AppNIC community trainer as well as a RIPE Atlas ambassador. So I distribute these RIPE Atlas probes as well, and hopefully probably in the first week I'll be also doing a small little webinar on that. And at my day job, I run a company called as Shrestha IT Technologies Private Limited, based out of Belgaum, where we build and secure networks of small medium enterprises as well as network operators in tier 2 and tier 3 cities. So that's all about me. So the agenda for today is, so I'll be talking roughly for 45 minutes. The whole session is ideally 45 minutes and may extend depending on the interaction. There are other speakers as well, so we'll see how it goes. But I'll talk about what is passive DNS. I will also outline the benefits of using passive DNS, who should be using passive DNS, and what is the value in using it, as well as focus on a couple of use cases which I have personally, worked on in the last few months, which will probably give you an idea of how passive DNS can help in number of ways. Questions at any point of time. I can see a lot of people have joined in via Zoom, and I can also see there are people watching on the YouTube stream as well. So anytime you have any questions, please go ahead and put the questions in the Q&A in Zoom, or raise a hand, the raise hand button which you see there, and maybe if you'd like to ask the question verbally. In case you are seeing this on YouTube, please go ahead and put it in the chat. I am monitoring all input channels for questions, so I will look into that. Plus, there is the null Bangalore Discord channel as well, which I am not seeing in any monitor at this point of time, but hopefully I will see it probably in a couple of minutes and see if there are any questions. All right, so passive DNS 101. The passive DNS as a architecture or as a system was first introduced by Florian Weimar at a paper which he presented at the first conference in 2004. So the idea is very simple. It's basically collecting cache miss traffic using software or sensors at the recursive resolvers, and I probably cover on the DNS element or the DNS fundamentals as well, probably as we move along. So the whole idea is to collect cache miss traffic. When I say cache miss, what I mean by cache miss is primarily whenever a DNS query hits a recursive resolver will check if the answer is already present in its cache. If it is already present in its cache, it will give the response back to the client or the stub resolver. And assuming that the answer does not exist, then what the recursive resolver will do is recursively fetch the answer, go down the delegation chain, and I'll cover that in a bit for people who may not be familiar with DNS as a whole. So there is a passive DNS common output format, and this format is something that generally all the passive DNS operators or vendors use. There is a RFC which talks about this passive DNS common output format. The authors are mentioned in this specific slide. I have a link to this in the references section. So if you're interested to read about the format of the passive DNS structure or data structure more specifically, you can look into that. Right, fundamentals of DNS, just going to go through this briefly so that people who may not be familiar with DNS will get a quick intro with regards to what is happening behind the scenes. And so let me go through this representation, the image that you see on the slide. So on the left-hand side, you have a device or a computer, which is where the user is asking the question or the user is accessing the domain name in the browser. So the question is, what is the IP address of brainattic.in? And so what happens is, as you may already know, DNS is domain name system, that is conversion of names to IPs and IPs to names. But more specifically, most people use it for in the general, without knowing it, unknowingly use domains DNS for conversion of names to IPs, right? So what is happening behind the scenes is the request from the computer or the device goes to something called as a stub resolver. So the stub resolver is a piece of code in every operating system which takes the query, the DNS query, and sends it to the recursive resolver. So recursive resolver, recursive DNS server, DNS server in the network, these are all common terms which people refer to. But the whole job of the recursive DNS server or the recursive resolver is to take the DNS query which clients or devices or stub resolvers are sending it and find the answer. So in this case, the question was, what is the IP address of brainattic.in? And when the request went to the recursive resolver took the question and looked into its cache. Now let's assume that it did not have the answer already. So what it did was it sent this query to the root server. So DNS is basically a hierarchical database. So everything starts at the root. And there are 13 root servers. But more practically or more specifically, there are 1086 instances of the root servers all around the world using a technology called as Anycast. So once the request goes to root servers, the question the recursive resolver is asking to the root servers is, what is the IP address of brainattic.in, which is my domain name. The root servers give a response back, and I'm simplifying here, but the root servers give a response back saying that, hey, I don't know what is the answer of what is the IP address of brainattic.in, but I do know what servers are responsible or authoritative for .in. So with that information, the recursive resolver now again sends a query to the .in servers, asking the same question again. Hey, what is the IP address of brainattic.in? The in servers respond back saying that, hey, I don't know what is the IP address of brainattic.in, but I do know what is the IP address of I know the name servers which are responsible for brainattic.in. So the recursive resolver with this information now sends the DNS query back to the authoritative servers of brainattic.in, and one of those servers will respond back saying, here is we are the authoritative servers, or I am the authoritative server, and here is the IP address of brainattic.in. And the recursive resolver will now take this answer, store it in its cache, and then give the response back to the stub resolver, and then the device will make a connection on port 80 or port 443 or whatever it is trying to do. So this is what is happening behind the scenes with regards to fundamentals of DNS, and I have simplified it to a very basic level to wherever required, but there are many other parts to it which I have not covered in this specific explanation. So moving along, in the case of passive DNS, if I have to now talk about passive DNS, what is happening here is the image is very similar to what you have seen in the previous slide. The only difference is, in this case, the point that I'm trying to make here is there are three computers at the bottom of the image or in the image, and each computer or each device is asking a question, right? It is asking a DNS query. So in this case, the first one is asking what is the IP address. DNSA stands for DNSA record. What is the IP address of r2-d2.info? The second one is asking for the MX record, which is the mail exchanger record, for the domain name c-3po.info. And the third one is asking a question, sdinet.info. What is the DNSA record? So all these questions from the devices are basically going to a recursive resolver, which may be in the network, or maybe an open resolver like 8.8.8.8 or 1.1, whatever it might be. So in this case, the example you can see is the recursive resolver is only asking the question to the upstream root. That is, what is the IP address of r2-d2.info? Which means that is the domain name which I'm trying to make you understand is a domain name which did not was not in the cache, and that is the reason why it's cache miss. So since the answer to that DNS record was not in the DNS cache of the recursive resolver has to fetch the answer. So that is cache miss traffic, that is cache miss transaction. So the passive DNS architecture comes in this specific picture where a software ideally, which is also called as a passive DNS sensor, is installed on a recursive resolver. This is not happening on all recursive resolvers. This has to be explicitly done. So it is installed on a recursive resolver, and the recursive resolver is doing its operation ideally as I outlined in fundamentals of DNS. But the sensor is now collecting the cache miss traffic, and it is sending it to a collection database called as a passive DNS database. And there are a lot of other elements to it with regards to passing that output, as well as making sure that the data is not duplicate, etc., etc. So all that is a very complex architecture, and that is something that I'm not covering here. But I hope you get the point. It is just the cache miss traffic which is getting sent to the passive DNS sensor or the passive DNS database for that matter. And I will go to the passive DNS operators, but all the passive DNS operators are primarily based on what I know are not collecting PII, that is personally identifiable information. So as based on what I know, they are not collecting, they're not looking at information about the source IP addresses or other such PII for that matter. Any questions at any point of it, please go ahead and put it in the Q&A. So I see a question from Giridhar. The question is, will the data also get saved on .in and root server at the same? I believe, if I understand it correctly, in the job of the recursive resolver, which is going down the delegation chain, I'm assuming that you're asking if the response is cached there. Technically, the recursive resolver as well as the devices are caching the responses. The root servers as well as your .in servers or authoritative servers for that matter, they are not ideally doing a caching for that matter. So every request that comes to them, say for example, I'm running an authoritative server for my domain brainattic.in. Every request that comes into it will be responded by the name server daemon. Right. Moving along, so why passive DNS from a security context, from a threat hunting perspective or penetration angle? Why passive DNS? Why is this important? So everything begins with a DNS query. No matter what you do on the internet, DNS plays a big and a major part in it. And the same is true for not only the internet that you and me access on a day-to-day basis for legitimate purposes or for day-to-day life, which is not abusive or which is not going to cause any harm to anyone. But at the same time, DNS is also used and abused by the bad actors in ways in which which will I would say give them a leverage with regards to performing crime or for that matter spreading malware on the internet as well as in the network, etc. So the abuse is the abuse also of the proliferation of this is also something where DNS plays a part. Because the system is not differentiating between legitimate query and a bad query per se. So phishing domains, a very common and easy example, you would have come across phishing domains which are impersonating a bank or Gmail login or PayPal login. So you would also see that there are various ways in which phishing is carried out, and I'll probably gloss over this this example. But before I do that, just to give you an understanding with regards to, let me step back a bit and probably share my terminal screen. Give me a minute. Right. So I'm hoping that you are able to see the terminal screen. In case if you're not, please go ahead and let me know in the chat in Zoom or YouTube for that matter. So what I'll demonstrate is so the element of the fundamentals of DNS which I talked about. The one quick way in which I will demonstrate this is by using a tool, a command called as drill. So what this will do is this will send a DNS query from my machine to the recursive resolver, and I run a recursive resolver in my network. So if you see, as I mentioned earlier, the query is first sent to the root servers. So there are 13 root servers in total. The question is asked to one of these root servers, what is the IP address of Brainattic? There is a respond back saying that I don't know what is IP address of Brainattic, but since you asked .in, I know which servers are responsible for .in. So these are the servers responsible for .in. So the recursive resolver then sends a query to one of these authoritative servers of .in and asking the question, what is the IP address of Brainattic.in? So one of these servers respond back saying that I don't know what is IP address of Brainattic.in, but I know the servers which are responsible or which are authoritative for Brainattic.in, and these are the servers. So the recursive resolver now makes a question or sends a query, DNS query to these authoritative servers. And these servers now respond back saying that, hey, I am the authoritative server. and the IP address of brainattic.in is so and so. So another tool that you can also use to do this is say, for example, Dick. So this tells you that, in this case, the thing that I'm trying to point out to you is I run a recursive resolver on my not only my network but even my system. So there is a recursive resolver which is running in my system, which is responding with the answer. So even for the drill command which I outlined here, it is a recursive resolver running on my MacBook which responded. Okay. So coming back to passive DNS, so why passive DNS? The whole point of uh, uh, using domain data or DNS data for domain names, primarily, more specifically to for abuse or for crime, is something that is the system is also abused in that way. So legitimate domains. So one of the ways in which the attack primarily goes is, so there are legitimate domains which are compromised in the sense that they are running a vulnerable instance of a, let's say, as an example, a content management software such as WordPress or something else, and due to a vulnerability, due to not having it updated, that would get compromised, and then the bad actors would put or host phishing content on that specific domain. So these are the domains which are ideally, I would say, domains which are for legitimate purposes. These are registered by legitimate users like you and me, and but due to an ignorance with respect to security, these domains have got compromised and they are being abused by the bad actors. But there is another a variation to this. There are also domains which are registered by the bad actors for malicious purposes. So as an example, somebody would register instead of paypal.com, paypal.com, somebody would register paypal.com, right? And that's primarily host login or pages with relating to impersonating paypal.com. So that those are the second criteria, or the second domains which are being abused primarily, and probably I'll show a few examples there as well. The other thing is domain names are cheap. So 99% of the domains which are registered are primarily used for malicious purposes. So what does passive DNS do? So the passive DNS basically, with multiple sensors all around the world, different passive DNS operators have different number of sensors, as well as the amount of data, cache miss data that they collect. But irrespective, the idea is the same. With the cache miss traffic which is being collected by the passive DNS sensors, this information is then collated in a centralized database, which has information like when was this domain name queried, as well as what was the IP address at a certain point of time. So at point A in history, let's say 1 month ago, the IP address of this domain name was pointing to let's say A, and now it is pointing to B. So you get a picture with regards, a holistic picture which you would not otherwise have got. So it basically allows you to correlate domain names as well as IP addresses and name servers, so all kind of DNS records, and provide a mapping between these DNS records. And one of the very important point which I kind of missed is the element that doing a forward lookup always poses a risk. So as an example, say for example, if I come across a phishing domain, and if I use the phishing domain to not only resolve on my machine, but even try to access it in let's say in the browser, there is a huge risk involved with regards to that domain might be having some malicious content which may get executed in my browser, or which may get downloaded. It poses a lot of risk to do something actively here. So investigation with regards to actively looking at what it is doing is riskier, but it can also be done in a manner in which it can be confined to say a virtual machine or a sandbox kind of an environment. But even if you do that, you still do not get the correlation between the other data that you're looking for, like what IP address. So if this domain name is pointing to this IP, what other resources, what other domain names are also using that IP, right? So this is what passive DNS ideally provides. It also provides what, let's say a domain name brainattic.in is using these 4 name servers, then which other domains are using those 4 name servers, right? So you basically get a mapping of this of the DNS database, which is super useful. So here is a quick glimpse into how this works. So this is an example where I'm trying to point out how the mapping would ideally work. So you have name servers. So one of the elements that you need to also understand is time is of essence for the good guys, as well as time is of essence for the bad guys. So the bad actors also have an shortage of time. So what they would do is instead of having different set of name servers for the domains that they own, what they would ideally do is the same name servers would be hosting or would be authoritative for thousands of domains which are putting malicious content on it, right, or having malicious content on it for whatever bad purposes that they have it. So with this fundamental uh, requirement of doing things fast for everyone, not only the good guys but even the bad guys, we can now map domain infrastructure or DNS infrastructure of the bad actors, such that we can figure out if the same name servers are also being used by other domains, or which other domains are using the same name servers for that matter. And probably once I give a demonstration, it might be a lot easier for you to follow and understand. So who should be using passive DNS? So anyone in security, malware researchers, SOC analysts, security professionals, law enforcement, penetration testers. It's useful. Anything that you are investigating with regards to DNS, no matter which field in security that you are working in, passive DNS will be extremely useful. So there are a few passive DNS operators. Spamhaus Technology is one, Farsight Security is another, RiskIQ, Circle, as well as VirusTotal. So there are many others. I have only outlined a few of the passive DNS operators which I have seen as well as experimented with. So in this context, a lot of passive DNS operators are commercial, so you need to buy a subscription. But a lot of them also provide a free account. So as an example, Spamhaus Technology provides a free account where you can get a passive DNS account by signing up, and I think it puts a limit of 200 queries per day, if I'm not mistaken. So you can go to the website. Farsight Security also has a community edition, if I'm not mistaken, and that is where you can get a of course with limits, but you can get a free account and you can use send queries to find out information in the database. So let's dive in. So this is so I'm going to demonstrate a lot of things here. So I hope I am doing well on time. So one of the things which I have been investigating for some time is the GoDaddy domain shadowing attack, and so this is an attack which primarily has been going on for quite some time. So this, I believe, a year or more than that. So the attack is something like GoDaddy. I'm not sure of the exact number, but based on this article, it says that 28,000 plus customers or 28,000 customers were affected. But I still keep seeing more and more data with regards to domains where GoDaddy name servers are authoritative. So the attack goes something like this. Bad actors create. So if you are as an example, if one of your domains at GoDaddy is affected, and your domain name is domain.tld as an example, the bad actors would have created a subdomain pxi or something like that with a CNAME pointing to one of their subdomain or DNS infrastructure, and that specific domain is pointing to an IP address. The domain pxi.domain, so domain.tld contains scripts, phishing, spam, etc. And I could find out that this is belonging to one specific AS. So there is a detailed look into this by Spamhaus. So there is an article, there is a link that I have put in the slides at the very end in the references section, so you can look into that. So current state of domain hijacking and a specific look at ongoing issues at GoDaddy. So here is an example. So this is a domain. So I specifically look at .in domains because .in is India. So here is an example which I could find sometime back, and I'll also demonstrate a few examples. Hopefully that the demo gods are with me today. So pxi.incometaxnotice.in. So incometaxnotice.in is some website, not by the government, based on what I could see, but it's somebody who puts some legitimate data on it. And uh, since the domain name had authoritative name servers which are by GoDaddy, and this was the affected domain, so there was a breach at GoDaddy, and that is how attackers have managed to create these DNS records or subdomain records for that matter. But the alarming thing is that the people who have registered these domains, they have no clue that these subdomain records have been created, and they are pointing to bad actor DNS infrastructure, or they are pointing to malicious content for that matter. So the main domain is working without any issues. So people are ignorant on the fact that there is a subdomain that has been created and that is pointing somewhere else. Here is an example of an output from the passive DNS database, and I'll go through this. I'll probably skip this part, skip this as well, and I'll demonstrate what is happening. So here, on purpose to demonstrate, I have actively accessed this specific domain in a sandbox environment. Do not do this if you are testing. Do not take the domain name. I wouldn't recommend that, because there could be a lot of things that may be happening there, which you may not, it may be harmful in a lot of ways. So it ideally needs to be done in a confined environment or in a sandbox environment. So that is what I've done here, and that's the screenshot from the browser. So as you can see, fiskefresh.in is a domain name which is a legitimate domain name. So the domain name is not created for any kind of malicious purposes. But because of the GoDaddy breach, bad actors have managed to create a subdomain record, pxi.the domain, and that is pointing that has a CNAME, that is canonical name, which is pointing to their DNS infrastructure. And they have a server there. They have a web server which is having scripts. So there is a test.php. Here is another example where it is basically, this script is, if you can understand, is primarily used for sending spam, right? Let me go ahead and run through a few examples, and I see a few people waiting for to be admitted to the waiting room. Let me see how we could add them. All right. So what you have basically is, I have a few scripts. So I'm here in this context for the demo. I'm primarily using Spamhaus technology passive DNS database, but it will work similarly for any other passive DNS database as well. So just to give you an example, let me. So here is a script. So ideally, the way this works is they provide an API, and once you have a free account, you would ideally put your username and password here. So this is a placeholder, and then what you would do is you would ideally access the API, which would generate something called as a token, a bearer token, and the bearer token is the one which you use to send queries to the passive DNS database. I see a question in the Zoom chat. Ishan has a question. The question is, so how to remove these records if someone detects these malicious subdomains? Yeah. So I'll probably keep this question to the end, because I have certain recommendations with regards to how do you manage this part as well. So moving along, so let's look into how do we do this. So once you send the once you send the username and password, you would ideally get a token of which is called as a bearer token, and that is the one that you would ideally use to the one to send the queries to your passive DNS database, right? Okay, so let's go ahead and look into. So what I've done is I've already done that part. So let me send a query and let me see if I can give an example. So for the case of simplicity, So what I'm doing here is I'm sending a query. So just to summarize, let me show you the page. So there is a documentation page that they have for accessing the API. So as I mentioned, you send the username and password, which you get after you generate a free account, and then you send it to the API. It will send you back the token. In my case, what I've done is I am storing the token in a variable, and I'm passing it to the query. So here what I'm doing is I'm asking the question to the passive DNS database, and the question is, give me all the resource records for the domain null.co.in. Any means any resource record for that matter. And this is something called as search type. EM stands for exact match. So let's do this. And you can see that the passive DNS database has given a response, which is nothing but JSON, JavaScript object notation. Okay, hold on. Let me see if I can make Riddhi the host as well. Right. Okay. So if you can see the output, so what I've done is I have sent a query, which is null.co.in, to the passive DNS database. And the question is, give me all the resource records which are in the passive DNS database for null.co.in. Any means any DNS record. S type or search type is exact match. So I'll demonstrate these couple of examples. So you see that you are getting a JSON object, you're getting a JSON data, and what you're able to see here is basically a lot of information about the domain. So you can see that in the passive DNS database, the IP address of null.co.in is this. As well as you have something called as time_last, which means that when was this record seen in the passive DNS database. So what I can do is, so this is epoch time. So I can take this, and I have a script which I have written, which is h time. So it's basically nothing to do with passive DNS, but this converts epoch time to time which is more comfortable to read. So this tells me that in the passive DNS database, this record was seen at on 20th of August at 8:55. Let's look at more records. So it also tells me that the name servers of null.co.in are these. And that's the beauty of it, because what you can also do now is I can take these name servers and I can send a query to the passive DNS database and ask the question, which other name servers which other domains are being used by these authoritative name servers. So when I do that, you will see that you will see that. So when I do that, you will see the answer that there are all these other domains which are also using the DNS authoritative name servers of null.co.in. So you are able to now map the interconnections. So I could see there was one domain. Of course, null.co.in is the main domain, is a legitimate domain. But let's imagine that null.co.in was a bad domain. So in this case, I would find out what records are there for null.co.in. And then what I could do is I could then look into what other name servers or what name servers of null.co.in are also authoritative for other domains. So this is the mapping, this is the interconnection of DNS record which passive DNS provides. And this is super useful because it gives you a lot of insight into what the bad actors are primarily doing, as well as what other domains are being used. I can also do something like this. So taking the previous query again, I run for null.co.in. If I scroll, you can see that it is in the passive DNS, the IP address was this. So what I can do is I can send a query to the passive DNS database asking for what other domains are also using the same IP address, right? So at this point of time, it looks like there is no other domain. And if I also see where this points to, let us find out. I'm sorry, let us find out. So I have a script IP to ASN, which maps what autonomous system does this IP address belong to. So it tells me that this is this is a server on DigitalOcean, most likely a a virtual private server or a dedicated server for that matter. And so there are no other domains in this context, right? Any questions? Anybody has any questions with regards to whatever I've demonstrated so far? Anybody would like to ask a question verbally who is present in the Zoom chat for that matter? What you could also do is, so I am also interested in what other domains are having the word null in it, right? So this is called as a word match. So this also matches, specific words or specific word in this case. So I'm more interested in finding out. So if you're a brand and if you're interested about domain names which are being registered for, say for example, a bank as an example, and you are interested in finding out if somebody is registering a domain name with your name in it, right? So you would use something like a word match to look into the passive DNS database. And as an example here, I'm able to see that there are these subdomain records as well as the main domain which have been registered, which have null in it. What you can also do is, as an example, say for example, I want to find out for the domain hdfcbank.com, I want to find out, use a feature called as fuzzy search. So fuzzy search basically allows you to look into similar domains which one character maybe modification in the domain name. So in this case, what I'm doing is I'm sending a query to the passive DNS database asking the question, the domain is hdfcbank.com. I want to find out if there is any other domain which is similar to hdfcbank.com with a character changed here and there. So let's look into that. And most probably, so wow. And if you can see, there are a few entries here. This looks a lot fishy. Sometimes it is also the domain squatters, people who register domains primarily to hold on it and sell it at a much larger price. But there are also possibilities that bad actors would register something similar to impersonate or for a phishing attack for that matter. I can also do this for something like, say, PayPal, which is abused in a lot of ways, and I'm sure this looks a lot fishy for that matter, because obviously the name is appears to be as well as this one, right? So you get a picture with regards to how things would work. What we can also do is you can run a left match. So let me do that. And I've forgotten to type. So say, for example, I want to match all DNS records or all records in the passive DNS database with a left match. So what I mean is match the left-hand side part of the domain, and dot could be anything, right? So you can get an example or get an understanding that there are a lot of domains which have, as if you can see this specific record, this response, accounts.google.com.gold, right? So these are typical example records of, maybe not specifically this one, but that is how bad actors would create subdomain records under a legitimate domain, or have a have a domain and have subdomain records which are pointing to various other places. Right. So let me go back to. So here is a friend of mine, Chris, pointed out sometime back on Twitter, saying that he tweeted out saying, "Here is I received a very interesting SMS, and that was primarily for phishing." And when I looked into it, I could see that using passive DNS, I could see that the IP that that domain was pointing to had probably thousands of such domains, right? and people do not realize that it's just one domain for that matter. There would be ideally the most I have seen is lakhs and millions of domains primarily at the same using the same DNS infrastructure, and that is the real information threat intel that you can find out of passive DNS. Another thing which I regularly do is look at something like OpenFish. OpenFish is basically provides a community feed of phishing domains. So if you can go to openfish.com, and if you go to feeds, it provides a free feed. So if you go on this specific page, every 12 hours they'll refresh the list here, and this is provided for free. So if you look into this these domains, most of the domains are the ones which are legitimate, but which have been compromised because of a vulnerability on the software or the scripts that they're running. There are a few that you will find which are the most interesting, and probably I've outlined them here just to save some time. Are these if you this is something that I checked today morning. So I have just 4 minutes here, so I'll probably try to quickly wrap with regards to what I wanted to demonstrate. So you can see that this domain is primarily pointing to this IP based on what passive DNS database has seen, and these are the name servers. So as an example, as I mentioned, GoDaddy was the domain shadowing attack is just domain. GoDaddy is one of the domain name registers. There are other registers where this issue is also happening. So here this is more like a specific attack. So, and if I have to probably also show you as an example. Here are a few examples of the GoDaddy domain shadowing attack. So you can see that a subdomain.maindomain.com, and that is pointing to servers which are controlled by the bad actors. Here is one for Commonwealth Bank, and pretty much you can see that all of them have a SSL certificate on it. So ideally, a lot of people are under the impression that SSL certificate means security. That means it doesn't mean security. It is just communication between the client and the server is going to be encrypted. But apart from that, it is not giving you an authentic. It's not confirming that this is an authentic domain, right? Here is an example that it is using. Some of them are using Let's Encrypt. And I'll probably run through this. The slides are there on the null page. So at any point of time you want to look into that, you can go through these examples, making sure that you do not execute them directly on your system. Here is one for Apple. So the main domain is this is created by the bad actors, locatemydevice.cloud. But when you access it, it has a CNAME which points to something else which is hosted by the bad actors. Here is Bank of America. Here is UK tax refund form. This is something that I've already covered. This is the one which I showed you a while back on the command line. This is the domain which is this is something that I found just yesterday. Here is another one for PayPal, which is again explicitly created by the bad actors for performing a phishing attack. A bit of a plug. I'm doing not the same presentation, but a lot of variations to it at AppNIC 50, which is happening on the 9th of September. So at 10:25 under the first security track. So there is going to be a lot of more variations to it. So if you're interested in this topic, feel free to join. The registration is free. And also on 23rd of September, I am virtually sharing the screen with Dr. Paul Vixie and presenting on passive DNS as well as what I've been working on. So if you're interested, please feel free to join. That is a link, and I think I'll put the uploaded. I'll update these slides with these this information on the null page. With that, I think here are the references. Any questions, please feel free and let me know. I think I went overboard with regards to 1 minute. So I will take this opportunity to thank you for joining me on a weekend. And I'll probably see you on in the breakout room. So if you have any questions you want to discuss, and that won't be recorded, so that is something that you can join and have a conversation with regards to any questions that you may have. Thank you.
Thank you, Swapnil. Uh, so everyone, breakout room is open now, and you can join it. Um, yeah, I think Swapnil has already joined. But before you, uh, before you go to the breakout room, there is something that we want to say. Vanna has left already. Vanna, are you there? Hello. So the next talks, then the talks after next three talks will happen on OWASP YouTube channel. And so, guys, thank you for joining us. And you can visit the OWASP YouTube channel for the following talks. Thank you. Bye.